Alright, so in the previous two videos we have been able to fill up the first row and the second row. Alright, so in this video we are going to be looking for ways to fill up the third row. Please do well to look up the previous videos for proper understanding, but it's basically the same thing, still the same theory that governs everything. Alright, so in the third row we're given mass. Let's get at what was given to us. Okay, we were given mass. Mass is given as 1 kg. Okay, so mass equals 1 kg. We weren't given pressure. Pressure is unknown. We were given saturation temperature of 88 degrees Celsius. Temperature is 88 degrees Celsius. Okay. What else? We were given internal energy. Okay, sorry. We were given enthalpy 2576. Enthalpy was given H, total enthalpy 2576 kilojoules. Okay. Alright, so we need to obtain first the pressure. Okay, so it's simple. We'll look for the pressure corresponding to this saturation temperature of 88 degrees Celsius. So from saturated water and steam corresponding to the temperature equals 88 degrees Celsius. What is the pressure corresponding to it? Let's get to saturated water and steam. Okay, we're there. We'll look at the various temperatures. 88 degrees, this is 99. Okay, which means we need to turn back, we need to flip back. Okay, these are temperature columns. 88 degrees, 88 degrees. This is 88. Okay, this is 88 degrees here, and the pressure corresponding to it is simply 0.65. So which means the given pressure is 0.65. Okay, that's pressure column. All right, so 0.65. Therefore pressure P equals 0.65 bar. Okay, let's fill that up. We've obtained the pressure given as 0.65. Next is to find the volume. We weren't given dryness fraction, but we were given enthalpy. So before we can find the volume, we have to find the dryness fraction. So which means since we're given enthalpy, we can find dryness fraction. Okay, so total enthalpy was given as 2574. So we need to convert this to specific enthalpy. Recall, dryness fraction X is equal to specific enthalpy minus enthalpy at the fluid all over enthalpy between the fluid and the gas. So which means we have to convert this enthalpy to specific property. Alright, so to convert that, specific enthalpy is simply total enthalpy all over mass. That's equal to total enthalpy is 2574. Total enthalpy is simply 2576. So we have 2576 divided by the mass was given as 1 kg. We divide by 1. So which still means that specific enthalpy now is simply 2576 kilojoules per kilograms. Okay, so if we know this, now from saturated water and steam table corresponding to this given pressure 0.65 bar, we need to find what HF is. We also need to find what HFG is. So from saturated water and steam, okay, corresponding to 0.65 bar. Alright, so we need to find HF. So let's dive there now. Let me zoom this a bit. So 0.65 bar, okay, which is here. HF is this 369. Zero 0.65. Okay. Alright, so 369 is HF. Alright, that's column for HF. Middle is HFG. Don't forget. So HF simply gave us 369. and then middle is simply 2288 as HFG 2288. Alright, 369 for HF. So obtain HF as simply 369 kilojoules per kilograms. HFG simply is 2288 kilojoules per kilogram. So if we know this, we can simply what substitute into this equation to obtain the value of dryness fraction x. Therefore x equals, so we said HF specific internal energy, which we obtain to be what 2576 here. So we have this 2576 minus we have HF, and HF is simply this 369 all over HFG here is simply 2288. Okay, so this means dryness fraction x is equal to 2576 minus 369. That simply gives us 2207. So we'll have 2207 divided by 2288. So this simply implies that dryness fraction x is equal to divide 2288. That's 0.96. So we'll have dryness fraction to be 0.96. Okay, so dryness fraction is simply 0.96. That column is found. We'll fill it up. We'll have 0.96. So if we know this, we can simply find volume. Total volume V is simply what? Mass times dryness fraction times volume at the gas for that given pressure. Okay, so from saturated water and steam, okay, and steam at the pressure is 0.65 bar, we need to find what Vg is. Okay, so once again, let me take this up. 0.65 bar here. Okay, Vg is simply this 2.535. I hope I'm correct. Yep, I'm correct. So that's it, 2.535. So Vg is simply 2.535. Take this down a bit. 2.535 meter cube per kilograms. Okay, we'll have this to be Vg. So that simply implies that total volume V is now equal to, we said mass, and mass was given as 1 kg. So 1 times we have dryness fraction, we obtain that to be 0.96 times 0.96 times we have volume of the gas, which is simply 2.535. So this simply implies total volume is equal to, we simply have 2.43 meters cube. So that is the value for the volume. Okay, so let's fill it up. Volume is 2.43. Alright, so next is degree of superheat. Of course, we have enthalpy, so we can find degree of superheat. Okay, let's use enthalpy this time around to find degree of superheat. So of course, as always, you have to convert enthalpy to specific enthalpy, and we've already done that. Specific enthalpy, that has been done. H is simply total enthalpy divided by mass, and we obtain that value to still gives us the value of the enthalpy itself. Notwithstanding, okay, we'll have that to be this 2576 kilojoules per kilograms. 2576 kilojoules per kilogram. So we need to find temperature corresponding to this from the superheated steam table. Okay, so from superheated steam table, that's to obtain the superheated temperature at H equal to 2576 kilojoules per kilograms. Okay, so let's obtain the values of enthalpy, and then we can obtain the temperature corresponding to it. So we'll move now to superheated steam table. Okay, let's see. This is superheated steam. Alright, we're there. Now these are the values for enthalpy. Let me take this down a bit. So this very third lines, right? These are enthalpy values. Superheated steam here. Okay. Okay, still superheated steam. Okay, these are enthalpy values. The very third line represents enthalpy values. H. So these are different values. This is from 25. This is from 2501 and above, 2514 and above, and so on. We're looking for enthalpy at 2576. So this is what we're looking for, 2576. Okay, so let's get it and see. 2576 enthalpy here. No, this 256 is 258. Okay, so we should have it from here. This 256, 257. The third line is 259. This 26. Okay, so if we look up the superheated steam corresponding to 25 enthalpy, this is column for enthalpy. Please, I flipped, okay, because I couldn't find the values here, so I had to flip down here. So we still have superheated steam values here for enthalpy as well. So here enthalpy appears at the second stage. Okay, we have it here at stage 2. So we're looking for 2576. Okay, 2576. 2576. Okay, this is 254. Okay, where is 27? It's not here. 25 is 26. There is 27. It's not here. Remember, for here the second is the enthalpy. Okay, you can see it here, H. Okay, so 2576. Okay, I think it's coming down. This is 2500. Okay, this is enthalpy H. This is 2500. We have 27, so it lies here. 2500, 2576 lies here before 27. So we'll have 2500 and 2781. And their temperatures for 2500, its temperature, superheated temperature, is simply occurred at 375 degrees Celsius, while the other occurred at 400 degrees Celsius. So we have 375, we have 400 degrees Celsius, and their values is 2500, 2781, 2500, 2500. Of course, 2576 lies here. Then this is 2781. Temperature here corresponding to this 2500 is simply okay, let's get that again. So the temperatures are simply 375 and 400. So we'll have here 375, and then we'll have here 400. Okay, so this is temperature. We're looking for superheated temperature corresponding to this enthalpy. That's what we're looking for. Okay, all right, so as always we interpolate, and I said simply use the last to subtract other variables. So we'll have here 2781 minus the first one, 2500. So which means you'll see the same thing here. It becomes 400 minus 2. It becomes 400 minus 375. So I have 400 minus 375. Okay, all over. See the same thing. Now use the last 2781 minus the middle one, which is 2576. So that simply becomes the last temperature, which is 300, which is 400 minus superheated temperature, which is what we're looking for. Is superheated. Okay, so we obtain this 2781 minus 2500. That gives us 281 all over. We obtain 2781 minus 2576. That gives us 205 and that's equal to, okay, so next we'll obtain 400 minus 375. That should be 25. That's 25 all over, then 400 minus T superheated, so we'll keep that. Alright, okay. So from here now, 281 divides 205, we have, that simply gives us 1.37. Okay, and that's equal to, we have here 25 divided by 400 minus T superheated. So I simply said this 1.37 is something as here 1.37 divides by 1. Okay, so I can easily cross multiply here. 1 multiplies 25, 1.37 multiplies the whole of this. Okay, so if I do that, I'll simply have, alright, so from here I'll have 1 multiplies 25, that simply gives me 25, and that's equal to, here I have 1.37 multiplies the whole of this, so I have 1.37 into 400 minus T superheated. Okay, so from here 25 is equal to, now let's evaluate this. 1.37 multiplies 400, that gives us 548. Okay, minus 1.37 times T superheated gives us 1.37 T superheated. Okay, so let's send 548 over here. Now we simply have 25 minus 548, that's equal to minus 1.37 T superheated. So 25 minus 548 gives us, that gives us minus 523, and that's equal to minus 1.37 T superheated. Alright, so therefore we can make T superheated subject simply by dividing both sides by minus 1.37. So we simply have minus 523 divided minus 1.37. So this simply implies that T superheated is equal to, so that gives us 381.75 degrees Celsius. So this is now the superheated temperature, but therefore degree of Celsius, degree of superheat, sorry, is simply superheated temperature minus saturation temperature. So degree of superheat is equal to, superheated temperature gives us this 381.75 minus saturation temperature is simply 88 degrees. Right, yeah, 88 degrees was given, so that's simply minus 88. So this implies that degree of superheat is now equal to, and that's simply 293.75 degrees Celsius. So this gives us the degree of superheat. Okay, so we can fill up that column now. 293.75. Okay, we'll have it here. 293.75. Okay, finally we need to find the internal energy. Okay, we need to find the internal energy, and you know, specific internal energy U is simply equal to UF plus X UFG. Okay, so let's find the value of internal energy at the fluid and that at the fluid and gas. Okay, so simply UF, okay, from saturated water and steam, at the given pressure is 0.65 bar, we can obtain UF as simply, okay, so let's go to saturated water and steam now. Pressure is 0.5, it's not here, okay, 0.65 here. So we need to obtain UF, which is this, that's 369, right? Yeah, UF is 369 and UG is just next to it. 369 against 2492. Okay, 2492. Alright, so UF is simply 369 kilojoules per kilograms. Okay, and UG is simply 2492. Okay, that's UG 2492. Alright, so we can find UFG. UFG is simply UG. UFG is simply UG. UFG is simply UG minus UF. Okay, so we know UG, we know UF, we can find UFG. Okay, so UFG is equal to UG was giving us 2492 against 369. Okay, 2492. So we'll have 2492 minus 369. So this simply implies that UFG is equal to, so we'll have that to be 2123 kilojoules per kilogram. So then again, U is equal to UF plus X UFG. Okay, so specific internal energy UF simply give us 369 plus X is the dryness fraction, and we obtain dryness fraction to be 0.96. We obtained it to be 0.96, so we simply have 0.96 multiplying UFG. UFG gave us 2123. Okay, so specific internal energy is equal to 369 plus, so 0.96 times 2123. That gives us 2038.08. Okay, so plus 369. This implies specific internal energy is equal to 209. That simply gives us 2098.08 kilojoules per kilogram. So as always, you have to convert this to total property. Simply total internal energy is simply mass times specific internal energy. And although the mass was given as 1, okay, so the mass was given here as 1, so we simply have 1 times 2098.08, so which implies total internal energy still remains 2098.08 kilojoules. Okay, so that becomes the internal energy. So let's fill up that point. We have here to be 2098.08 kilojoules. Okay, so we have this. Alright, so as usual, I'll pause the video here, and in the next video I'll fill up the next column to avoid too much lengthiness of the video. Okay, so I'll pause it here.